Hey guys, it is Mrs. Ross, and I am here to talk to you about section 4.3 in Algebra 2. There was another recording that went over 4.1, introduced the idea of a quadratic equation. We're skipping 4.2, and we're diving right into 4.3. All right, so you might see something on your screen, but before we talk about that, I just want to tell you kind of where we are going with the next few sections. So you might say, why is all this coming back? So what we are talking about actually with the rest of this chapter is how do we solve quadratic equations? All right, so again, before chapter 4, we had linear equations, and we talked about different ways to solve linear equations. We even talked about how do we solve more than one linear equation, and we had a lot of tools to be able to do that. Well, this section and chapter 4, we're talking about quadratic equations and how do we solve quadratic equations. And so if you remember from the video, just 4.1, a quadratic equation looks like this: ax squared plus bx plus c equals some value y, right? So again, with linear equations, it was kind of nice because if we figured out what y was, like, y is equal to 100, and we didn't have this x squared or the x squared term, then we could solve for x and we were done. We were golden, right? But we have, now with quadratic equations, we have an x squared term. So we need to figure out how to solve for x, but we have an x squared term, so that makes it a lot harder to solve. So in 4.3, 4.4, 4.5, we are going to be talking about different techniques that we can use to solve the quadratic equation. So this is the first one. I know if you were in my Algebra 1 class, we did get to this right at the end of all the factoring and FOILing. Depending on what curriculum you have, you may or may not have gotten to this, but this is one of the big purposes of factoring quadratics, to be able to solve them. All right, so I'm going to take you to the end part and kind of tell you why are we doing this. So first of all, this is our quadratic equation, right? And what technique we learned was something called FOILing, where we were able to multiply linear terms together. And then we also talked about breaking them down into terms. So what I'm talking about is if we had a quadratic like this, then we would hopefully be able to get it into a format like this, where we have an x and some value 2 and 3 and a plus and a minus. All right, and this would be this. These two are the same, but they're just written in different formats, right? This is we consider this to be the factored version. Factored. Okay, and to go from the quadratic form to this linear factored form, we have to do, well, I should say the other way. To go from the factored to the quadratic, we use a technique called FOIL, right? Which is just basically a process of multiplying your first terms, your outside terms, your inside terms, and your last terms. Well, if we go this way, I like to say that we unfoil it. It's not an official technique, but that's basically what we're doing. We're trying to solve the mystery of how do we get from the quadratic to the factored term. All right, so again, why do we want to do this? Well, if we can get to a spot where we're able to factor a quadratic, so let's just take an example, okay? If I know that that my quadratic can be factored as x plus 2 and x minus 3, and that equals 0. If I can get my equation to this term, then I can actually solve my equation. All right, so how can I solve my equation? Well, this is not highly mathematical, but this is kind of how I like to say it. If you want an answer of 0, okay, you have two things multiplied together, and you want the answer to be 0, then one of those two things has to be 0. So either this has to be 0 or this has to be 0 in order for this to be 0. Because there's no combinations of numbers that you can multiply together to get an answer of 0 that doesn't have one of the two being 0. So I can't do -3 times 1/3 and get 0. I can't do 2,000 times 1/2000 and get 0. I can get 1, but I can't get 0, right? I have to have one of the two things I'm multiplying by has to be 0 for my answer to be 0. And then what I can do is say, well, if x plus 2 has to be 0, then one possible answer is x could be -2. And then another possible answer could be x equals 3. Because if I put in x equals 3, 3 minus 3 is 0, and then anything times 0 is 0. All right, so that's kind of the end piece that we're going to get to. But before we get there, we are going to do some practice factoring. All right, so let me pull up a few of these examples here. So this is just to refresh your brain, if I can talk correctly, about factoring. Let's open these up. So these first 4 are just straight quadratic equations. These are all quadratic equations. They have this squared term. Just because they're not x squared, they're still quadratics. So we want to look at each one and see if we can factor. So I'm going to talk through my thought process as I try to factor each one of these, okay? So number 1, we have x squared minus 7x plus 10, okay? So what you're doing when you're trying to factor is you're trying to come up with these linear factors to see if we can break this down. So I know when I FOIL it, right, I'm going to do my first term. So my first terms need to multiply together to get x squared. So in order to get an x squared, I need to do an x times an x. So I'm pretty sure that's good. All right, so the F in FOIL stands for your first terms. We're going to ignore the O and the I for a minute, and we're going to go to the L, okay? The L term stands for my last term. My last term is a positive 10. All right, so I need to think of all the ways that I could multiply my last term together to get a positive 10. So I could do 1 times 10. I could do 2 times 5. 3, 4, 5, those are all the same. I could also do -1 times -10 or -2 times -5. All right, so when I look at these for my last term, all of these would work just to get my plus 10 at the end. But in order for me to get my inside outside to be -7x, all right, I need for my last terms when I add them together to give me -7. So 1 and 10 give me 11. 2 and 5 give me 7, but it's positive. So I think I'm going to use -2 and -5. -2, -5. All right, so what I do once I kind of make a guess is then I check. So I do FOIL to check. And I say my first term is x times x, x squared. My outside is x times -5, -5x. My inside is -2 times x, so -2x. And my last is -2 times -5, which is positive 10. So these equal -7x, and ta-da, I have factored this. Okay. All right, so let's keep going. Your brains are remembering, I know they are. Or maybe you're groaning, I'm not sure. But it's in there somewhere, right? Let's try number 2. So we have n squared minus 3n plus 9. Okay? All right, so I know in order to get an n squared, I have to do an n times an n. Okay, so that's my first term. Now I look at my last term. I have a 9, a positive 9, so I can get that 1 times 9, -1 times -9, -3 times -3, or +3 times +3. All right, so these are all my possible last term combinations. But then I go to look at my middle, and my middle is -3. All right, 1 and 9, -1 and -9, -3, -3, +3, +3. None of those combinations are going to give me a -3. So this particular one is not factorable. Mean trick, right? Not factorable. Okay. Okay, let me expand my screen because I want to keep this one up on here. Okay. All right. So purple, number 3. Number 3. We have q squared minus 100. All right. So even though we don't have a middle term, we can still factor this. So to get a q squared, I need a q times a q, right? To get 100 at the end, there's lots of different ways to make 100, but I have one huge clue that is telling me which combinations I want to make 100, because I could do, 1 times 100, I could do 4 times 25, I can do 10 times 10. Those are all ways that I can multiply to make 100. My huge clue here is that I have no middle number. I have no q term. So that means I have to cancel each other out. In order to cancel each other out, I need 2 numbers that are the same. So if I do 10 times -10, when I go to add those together, so I have q minus 10, q plus 10. When I go to FOIL to check my work, sorry for that crazy plus, I get q squared for my first. My outside is -10q. My inside, this is a no, this should be positive. My inside is -10q, and my last is -100. These guys cancel out, and I have factored it. If I write this right, I got to fix this because that's pretty bad. There we go, plus. Okay, and then number 4. We can sneak number 4 in here. Number 4, we have w squared minus 18w plus 81. Okay, so I know that my w is going to be w and w, right? And I have 81 here. And that kind of is one of those numbers that sticks in my brain. So I know 81 is 9 times 9, right? And if I do -9 times -9 and I add those together, I get -18. So I can write this as w minus 9, w minus 9, and it's been factored. And I wanted to do this one because I think it's important to note that sometimes this is written as w minus 9 squared. Okay, so that's factoring. I know I went kind of quickly through it, but we can review again. We can do more factoring if you'd like to on that. I want to kind of get to the good stuff as to why we're doing this, not to just torture you with factoring again, 2 subjects in a row. So let's go back to, let me see if I can just pull off this here. Okay, it's kind of messy, but you'll be able to see it. Okay, so if you remember, fill it in. There we go. All right, so if you remember example number 1, we have x squared minus 7x plus 10. And I said, okay, well, we can do this. And we factored it. And we said that these two, that's not what I want to do. Sorry, guys. That these two mean the same thing. So x squared minus 7x plus 10 and x minus 2 times x minus 5. Those are the same thing, right? This is in quadratic form. This is in factored form. What if I put equals 0 at the end? And all of a sudden I said, okay, now solve it. Tell me what x's make this equation true. What x do I put in that makes x squared minus 7x plus 10 equal to 0? What's true? So this is where that weird something times something comes into play. So if I know that x minus 2, this is the factored term, right, times x minus 5 equals 0, that means that x minus 2 has to be 0 because either this thing has to be 0 or this thing has to be 0. One of those two has to be 0. So x could be 2. That's one way to make this equation 0. Another way to make the equation 0 is x minus 5 could be 0 or x could be 5. Those are the two solutions to my equation. So you might be saying, okay, Mrs. Ross, there's two answers. Yes, there's two answers. The reason there's two answers is because we have this squared term here. So we have more than one solution. All right, so now we're going to bring this completely full circle, and I want to show you this on Desmos on your graphing tool. So grab your graphing tool, and hopefully this will all kind of click together for you. And we'll do another example like this, but, oh, don't have Desmos up. Okay, so our equation was x squared, right, minus 7x plus 10. All right, and we wanted to know where it equals 0. Now that kind of made our graph go crazy. We're not going to put that on there, right? Now, we want to know when does my value, when does my whole equation equal 0? Well, when does this equal 0? Well, that equals 0 when y equals 0, right? So I'm just going to graph that on there so we have it. And then, yeah, so we just talked about the other section. This is where the vertex is, right? But there's these two other interesting points. All right, so when x equals 2, y equals 0. And when x equals 5, y equals 0. These numbers should look familiar because when we solved our quadratic equation back here, this big messy looking thing, we said that my zeros were when x equals 2 and x equals 5. So this is why we actually do the factoring method, why we do all that work, so that we are able to solve the equation. Kind of all comes full circle for that. So I want to do one more and then let you guys go on your way. All right, so we're going to do example 5, and then when I get back on Thursday the 16th, we'll kind of review this a little bit more because I think it's a really important concept. All right, so number 5, this is from your notes page, says we have x squared plus 2x minus 35 equals 0, okay? And I want to know what x's make this true. So what do I plug in for x that makes my whole equation equal to 0? That's what I'm trying to do. Okay, so the way that it's written right now, I can't do anything. I can't solve for x. I could send, 2x to the other side, but then I have this x squared, and that's kind of a mess. So what I'm going to try to do, the first kind of that you should kind of try out to do is to see if you can factor it. All right, so let's see if we can factor it. So I know factoring always looks like this, right? So I know to get x squared, I need to do x times x. Here I have a negative 35. So in order to get my last term of a negative 35, I could do negative 1 times positive 35, right? I could do negative 5 times positive 7. I could do positive 5 times negative 7, and I could do positive 1 times negative 35. So which combination of these added together gives me a positive 2? So if I do negative 5 and positive 7, so x minus 5 and x plus 7, and if you FOIL that to check it, this is the factor of that, okay? So I factored it. Wonderful, right? Now I want to know what values of x make this equal to 0 or this equal to 0, okay? So if I want to put x minus 5 and I want to make that whole thing 0, x minus 5 could be 0. That means when x equals 5, that's one possible answer to my equation. The other possible answer is x plus 7 equals 0. So that's when x equals negative 7 is the solution, negative 7, right in there. All right, so there's a couple ways to check your work here. One is, and we didn't do this last time, is I could just put it in. So I'm just going to pick one, the x equals 5, okay? And remember, this is my original equation. So x squared plus 2x minus 35, I want it to be equal to 0, okay? So I plug in this, I get 5 squared plus 2 times 5 minus 35. This is 25 plus 10 minus 35, and voila, we get 0 equals 0. So that's the actual solution, right? If you plug in negative 7, that's going to work out the same way. If we flip to Desmos and we graph this, okay, so our original equation was x squared plus 2x minus 35. There we go. And then just to double check yourself, you can put in your factored equation. So remember we said it's x minus 5 times x plus 7. So if you did your factoring right, then they should be directly on top of each other, which they are, right? The green and the orange are the same graph. So it doesn't matter which one you do. All right. So now, if you recall, we said that our zeros are when x equals 5 and when x equals negative 7. So the graph actually supports the algebra that we did to figure out what the zeros of the equation are. All right, so that is fun with quadratics and finding zeros. You guys can go ahead and try 4-3. There's a couple examples we didn't get to at the end, and we will do more work with this on the 16th. So hope you guys are doing well, and I'll talk to you soon.